January 11th, 2024. The Arabian Sea off the coast of Somalia. The ocean is rough. Swells are building. Visibility is near zero. On the mission deck of the USS Lewis B puller, Navy SEALs prepare to launch. Their target, a dhow carrying Iranian ballistic and cruise missile components bound for the Houthis in Yemen. Helicopters spin up on the flight deck above. Drones provide overwatch. The boarding team climbs into rigid hull inflatable boats and heads into the dark. They reach the dhow. They board. They seize the weapons, propulsion systems, guidance packages, warheads. Mission success. But the sea isn't finished. During the boarding, one SEAL falls into the water while climbing a ladder between the small boat and the dhow. The waves are too strong. A second SEAL jumps in after him. Both are lost. The Navy searches for 10 days before declaring them deceased. The mission was completed. The weapons were seized. But two operators paid the price of working in rough seas from a ship that sits in contested waters year-round through every storm season the Arabian Sea and Persian Gulf can produce. How does a converted oil tanker, 785 feet long, flat-decked, barely armed, with a maximum speed of 15 knots, survive the kind of seas that took two of America's most elite warriors? The ship can't outrun a storm. It doesn't retreat to port. It has been deployed to the 5th Fleet area of operations since 2017 without ever coming home. So when the ocean turns violent, the crew has one option: ride it out. And here's the part most people never ask. This ship doesn't just survive storms, it operates through them, launches missions, recovers aircraft, keeps station, while destroyers and carriers reposition around it. How? The answer starts with where this hull was born. And it wasn't the Persian Gulf. The Gulf of Alaska. If you want to understand why the Expeditionary Sea Base survives rough seas, start there. The Gulf of Alaska is one of the most violent stretches of ocean on the planet. Winter storms regularly stack 30-foot waves across hundreds of miles of open water. Hurricane-force winds rip through with punishing regularity. The Aleutian Low, a semi-permanent low-pressure system, generates storm after storm from October through March, turning the Gulf into a machine that has been battering ships for centuries. This is the water the Expeditionary Sea Base's hull was designed for. General Dynamics NASSCO in San Diego built the Alaska-class oil tanker for BP in the early 2000s. These ships haul crude oil from Valdez, Alaska, to refineries on the U.S. West Coast. Every voyage crosses the Gulf of Alaska. Every voyage means exposure to some of the worst sea conditions on Earth. So NASSCO built them to take it. Double hull construction with a designed hull life of 35 years and a deck life of 50 years. A beam of 164 feet, extraordinarily wide, gives the ship massive inherent stability. Diesel-electric propulsion with twin screws and twin rudders provides redundancy. If one system fails in a storm, the other keeps the ship on course. When the Navy needed a cheap, deployable platform for special operations and mine warfare, they took this hull, proven in the Gulf of Alaska, and converted it into a warship. They added the flight deck, the mission deck, the command spaces, and the armories. But the bones stayed the same. The hull that hauled crude oil through 30-foot North Pacific swells now hauls SEALs, helicopters, and weapons through the Arabian Sea. The ESB displaces 90,000 tons. It draws 40 feet of water. That displacement and draft mean the ship's center of gravity sits deep below the waterline. In rough seas, a deep center of gravity resists rolling. A 164-foot beam creates an enormous righting moment. When the ship tilts, the wide hull generates buoyancy forces that push it back upright. And at 90,000 tons, the ship has so much inertia that individual waves cannot throw it around the way they would hammer a 9,000-ton destroyer. The physics are simple: big, wide, heavy, and deep. The same proportions that make the ESB look ungainly in calm water make it one of the most stable platforms in the Navy when the ocean gets violent. But a stable hull is just the starting point. When a storm hits, keeping this ship operational takes a crew unlike any other in the fleet. When a storm builds in the Persian Gulf, most warships have options. A destroyer can increase speed and reposition. An amphibious ship can adjust course. The ESB has one option: sit there and take it. 15 knots, that's top speed. You're not outrunning anything. When a shamal, one of the sudden violent dust storms that rip across the Persian Gulf with winds reaching 40 knots or more and swells that build in hours, comes through, the puller is exactly where it was before the storm hit. And that's by design, because the crew that sails this ship was built for exactly this scenario. The ESB runs on a hybrid model. 44 civilian mariners from Military Sealift Command work from the aft superstructure. About 100 Navy sailors work from the forward superstructure, two separate chains of command on one hull. When heavy weather hits, that split becomes the ship's greatest asset. On the bridge, the civilian mate on watch controls navigation and ship handling. These aren't fresh recruits. They're professional merchant mariners, many with decades of experience on commercial tankers and cargo vessels. They've sailed through North Atlantic gales, Gulf of Alaska winters, and typhoon seasons in the Western Pacific. Handling a ship in rough seas isn't a drill for them. It's Tuesday. The mate on watch makes the critical heavy weather decisions. Course adjustments to quarter the seas, angling the ship so waves hit the bow at roughly 45 degrees rather than broadside, reducing roll and keeping the motion predictable. Speed changes to prevent slamming. When the bow lifts out of a wave trough and crashes into the next crest, the impact can stress the hull and injure the crew. Slowing down softens the blow, heading adjustments to avoid taking waves directly on the beam, which produces the worst rolling. These are decisions commercial tanker officers make instinctively after years at sea, and on the ESB, they make them for a warship. Below the bridge, the ballast control team works the system that keeps the ship upright. This is where the tanker DNA becomes critical. The ESB inherited the Alaska class's extensive ballast tank network, tanks built into the hull that can be filled or emptied to adjust draft, trim, and stability in real time. When seas build, the ballast engineers pump seawater into designated tanks. Thousands of tons of water flow into the hull, lowering the center of gravity, increasing draft, making the ship heavier and harder to move. But there is a danger most people never think about: partially filled tanks. Liquid inside a tank that is not completely full sloshes from side to side with each roll. That sloshing shifts the center of gravity. The ship rolls left, the water rushes left, amplifying the motion. Each cycle gets worse. Naval architects call it the free surface effect, and it has capsized ships. The ballast team prevents this by following a rule tanker crews learn on day one: tanks stay either completely full or completely empty, never in between during heavy weather. Thousands of tons of seawater managed with precision keep the ship's physics in check while the ocean tries to tip it over. Meanwhile, the Navy side handles everything on the mission deck and flight deck. Containerized modules weighing tons get lashed to the deck with chains and turnbuckles. Combat craft assault vessels are secured in their cradles. Unmanned vehicles are locked down. The 11 metric ton crane, rated for Sea State 3 with waves of roughly 4 feet, gets locked and stowed the moment conditions exceed its limits. On the flight deck above, helicopters are chained to the deck with tie-downs rated for storm loads or struck below into the hangar. All flight operations stop. Boat launches cease. The Scan Eagle drones stay in their containers. The 52,000 square foot flight deck goes quiet. The mission pauses, but the ship does not. It keeps station, keeps the ballast balanced, keeps the crew ready. The moment the weather breaks, operations resume, cranes unlock, boats launch, helicopters spin up. The speed of that recovery is the ESB's real advantage. Not avoiding the storm, but being the first platform back in action when it passes. If you're starting to see why a converted oil tanker might handle storms better than warships costing 10 times as much, hit that subscribe button. Because the proof isn't in the engineering, it's in what this ship has done while every other platform came and went. The USS Lewis B puller has been forward deployed since 2017. 8 years through every Somali season, through every monsoon cycle, through summer heat that pushes Persian Gulf surface temperatures above 90 degrees Fahrenheit. The hull never leaves. Blue and gold crews rotate every 5 months. The civilian mariners rotate on their own schedule. But the ship stays on station permanently while destroyers and carriers cycle through on 6 to 9 month deployments. And in those 8 years, the puller hasn't just survived the weather. It's operated through it. During a single 2021 deployment spanning the Arabian Gulf summer, including Somali season, the puller logged over 1,200 takeoffs and landings, 9 aircraft types from joint and coalition partners, more than 80 Scan Eagle drone missions, over 1,200 unmanned aerial vehicle flight hours, more than 1,000 hours of surveillance video across more than 20 intelligence target areas, all from a ship that can't outrun a storm and never tries. April 2020. The Persian Gulf. 11 Iranian Islamic Revolutionary Guard Corps patrol vessels circled the puller at 50 yards for an hour. The ship held position. It did not flinch. December 2022. The Gulf of Oman. Puller intercepted the Dow Marwan 1, seized over 1 million rounds of Iranian ammunition, sent them to Ukraine. January 2024, rough seas off Somalia. The SEAL raid. Iranian missile components seized. 2 operators lost to the waves. The mission was completed because the ship was there. That is the pattern. The Expeditionary Sea Base does not wait for good weather to operate. It operates through whatever comes. And when the sea's calm, it is the first platform back at full capacity because it never left. Every other ship in the region operates on a deployment cycle. They arrive, they work, they leave. The puller stays through the storms and between them, through 8 years of weather that has cycled dozens of other ships in and out of the 5th Fleet area of operations. 90,000 tons, 164-foot beam, 40-foot draft. The same ship people call a floating oil tanker is actually one of the most storm-resilient platforms in the entire Navy, and the crew that sails it knows exactly how to use every ton. January 11th, 2024. Rough seas. Darkness. 2 Navy SEALs lost to the waves off Somalia. The mission was completed. Iranian missile components seized. Not because the ship outran the storm or waited for calm water. Because it was there, on station, in the rough, the way it always is. The puller does not look like a ship built to survive the ocean's worst. No armor, 12 machine guns, 15 knots. But underneath that flight deck sits a tanker hull born in the Gulf of Alaska, one of the most violent stretches of water on Earth. A ballast system shifts thousands of tons of seawater to keep the ship's physics in check. The crew is split between civilian mariners who have spent careers riding out heavy weather and Navy sailors trained to secure everything that moves. The ocean is the one threat you cannot shoot down, jam, or outmaneuver. The Expeditionary Sea Base does not try. It just stays. 90,000 tons of steel and tanker engineering planted in the same spot through every storm the Arabian Sea can produce. Other ships deploy and leave. This one arrived in 2017 and never went home. That's not a weakness, that's the whole point.